All right, we're continuing with more example problems from the Isosceles triangle section of the textbook, where we learned about isosceles triangles, but we also learned about important auxiliary lines that we use to analyze triangles, like the median, the altitude, the angle bisector, etc. We also learned about the meaning of the perimeter of a triangle, and it really just the perimeter of a polygon, of any polygon, being the sum of the length of all of the sides of the polygon. Okay, this is a property of polygons, the perimeter. All right, so in this first question here, it says, suppose that BC is the base of isosceles triangle ABC, not shown. Find the perimeter of triangle ABC if AB is equal to 8 and BC is equal to 10. All right, so let's draw this isosceles triangle ABC, where BC is the base. So the base is the side, the third side that's not congruent, that's not the congruent side. So if these two sides are congruent, because the triangle is isosceles, then that would mean that the BC is the base and A must be the vertex angle. Okay, so with that, they want us to find the perimeter of this triangle. So we just need to sum the side lengths. And the information they give us is that AB is equal to 8. That means AC must be equal to 8, and BC is equal to 10. So the perimeter is just 8 plus 8 plus 10. Okay, same isosceles triangle, but now we want to find the perimeter, find the length of AB if the perimeter is 36.4 and BC is 14.6. So, okay, if we call these two side lengths x, they're the same, they're congruent, then we have x plus 14.6 is equal to 36.4. So 2x plus 14.6 is equal to 36.4. So 2x is equal to, so 36.4 minus 14.6, 21.8. Okay, so divide by 2, 10.9. Okay, same triangle, but it says find x if the perimeter of triangle ABC is 40, AB is equal to x, and BC is equal to x plus 4. Well, if AB is equal to x, then AC is equal to x. So we've got x plus x plus x plus 4 is equal to 40. So 3x plus 4 is equal to 40. Subtracting 4 from both sides. Okay. 36 divided by 3 is 12. So that x is equal to 12. Okay. Find x if the perimeter of triangle ABC is 68 and AB is equal to x. That means AC is equal to x, and BC is equal to 1.4x. So let's see, we can write 1.4 as 14 divided by 10. That's 7/5. So 7/5 x plus x is equal to 68. So 7/5 x plus 2x is equal to 68. You have 7/5 x plus 10 divided by 5x is equal to 68. So 17 divided by 5x is equal to 68. So x is equal to let's see, 68 divided by 17 is 4. So x is equal to 20. Suppose that triangle ABC is congruent to triangle DEF. Also, AX bisects CAB and DY bisects FDE. So, okay. All right. Are these corresponding angle bisectors of congruent triangles congruent? So they're asking, is AX congruent to DY? So let's remove these marks for now. And so it says triangle ABC is congruent to triangle DEF. So AB corresponds to DE. BC corresponds to EF. It's kind of hard to mark. We'll come back to that. AC corresponds to DF. Okay. Now, so we know that this is a bisector, but we don't know, and we know this is a bisector, but we don't know that these two angles are the same necessarily. Like all of angle A and all of angle D, like the entire angle A and the entire angle D are congruent. We don't know that yet. Okay, but we know that CB is congruent to EF. And so what that tells us is, or no, wait, I'm sorry, we do know that. Yeah, angle A corresponds to angle D. So, okay, never mind. These are congruent. Angle A, these are congruent triangles. Angle A corresponds to angle D. And in fact, angle B corresponds to angle E. And angle F corresponds to angle C. Well, okay, we're comparing triangles ACX and DFY. They're congruent by angle side angle. So that means these are congruent. And these are congruent. But since CB is congruent to FE from the original congruence, then these are congruent. But all we need to answer was that these angle bisectors are congruent. AX is congruent to DY. Okay, once again, suppose that triangle ABC is congruent to triangle DEF. And now AX, they're saying AX is the median from A to BC and from D to Y. So they're saying that these two are congruent and these two are congruent. But we can't say for sure yet that they're all congruent to each other. So, all right, so the AB corresponds to DE, AC corresponds to DF, just like before. Okay, and let's see, angle C corresponds to angle F, angle E corresponds to angle B. We're talking about this congruence right here. And so now angle A corresponds to angle D. That's true. But that doesn't allow us to say that like these angles are congruent because it doesn't. We don't have any information about a bisector. But we do know that since CB, yeah, we could have stated this in the beginning. Since CB and EF are congruent, they're congruent. Okay, we know that. And we know that Y is the bisector of FE and X is the bisection point of FE. Well, then these are congruent. Because we know that from originally, we know that AC or that BC is congruent to EF. They told us that. So yeah, I could have stated that in the beginning. So there you go. Side, angle, side. Congruence. So these two are congruent. The medians. So the whole point is that they're wanting us to note that corresponding medians and corresponding angle bisectors of congruent triangles are congruent. Corresponding anything of any congruent triangles are going to be congruent, you can think about. It's the same triangle. If you have two congruent triangles, then any feature that you add, as long as you're adding the same feature on the other triangle, it's going to be the same, they're going to be equivalent. It's the same triangle. All right, given angle 1 is congruent to angle 3, and RU is congruent to VU, prove that triangle STU is isosceles. All right, so yeah, with these proofs here, we're not doing official mathematical proofs with statements and reasons. We're going to do these proofs unofficially. That's how you would, as like an engineer or biologist, whatever. That's how you would make statements. You would do it informally, right? If you had a system and you were analyzing a system with this geometrical configuration here, and you wanted to show that triangle STU is isosceles, well, then this is kind of how you would do it informally. So, okay, since we know that, we know triangle RUV is isosceles with vertex angle U, so we know that these two angles are congruent, these two base angles, okay? So with that, then, we can say that by angle side angle, we can say that triangle RUS is congruent to triangle VUT. And I'll go ahead and put angle side angle, but you don't have to. Okay, so that means that corresponding sides are congruent. So US is congruent, corresponds to UT. So these two are congruent. And that's triangle STU. It's isosceles. Okay, given WY is congruent to WZ, so that's kind of hard to see. Let me see. I'm trying to put it kind of in the middle here. All right, and given that M is the midpoint of YZ, so these two sides are congruent. Given that MX is perpendicular to WY and MT is perpendicular to WZ, prove that MX is congruent to MT. Okay, so we can see that this big triangle WYZ is isosceles, and these are the base angles, which are congruent. It's isosceles. So we've got side angle. That's a congruence criteria because we can. That means that since the two angles are congruent, that means these two angles are congruent. So we have angle side angle. So okay, triangle XYM is congruent to triangle TZM by the side angle or angle side angle, whatever you want to put. And so XM corresponds to TM, which means that XM is congruent to TM, and there you go. The reason you would state would be the CPCTC reason. Okay, given isosceles triangle MNP, and it tells us the vertex is at P, so that means that this is congruent to this. MP is congruent to NP. Okay, isosceles triangle MNQ with vertex Q, so this is congruent to this. Prove that triangle MQP is congruent to triangle NQP. Okay, so these, let's look at base angles. These are base angles here of triangle MQN. So those are congruent. Now, these are base angles here of the big triangle. So those are congruent. But that means that you can see because the entire angle is congruent and because these two subparts are congruent, well, then these two angles must be congruent. We don't know that this is MQ bisects PMN, but we just know that these angles are congruent here. So we've got, all right, side angle side, comparing triangle MQP and NQP. We can state this congruence. There you go. All right, an isosceles triangle BAT, AT is congruent to AB. Okay, so they've already got these marks here, so let me try and, this is kind of confusing. I'll put these bigger marks kind of right in the center of AT. So AB is congruent to AT. Also, BR is congruent to BT. They have that shown. And BT is congruent to AR. All right, if AB is equal to 12.3, so that means AT is equal to 12.3, and AR is equal to 7.6. I'll put this kind of smaller. Find the perimeter of triangle BAT, triangle ARB, and triangle RBT. Okay. So this is 7.6. This is 7.6. So, okay, I guess we have enough information now that the perimeter of triangle BAT is, okay. We need, we're going to have to get RT eventually, but we can actually, we have enough information to get the perimeter of BAT. So BAT is 12.3 plus 12.3 plus 7.6. So 12.3 32.2. Okay. Now, let's see. If we subtract 12.3 from 7.6, we can get RT. So 4.7. You see, this is the entire length of AT is 12.3. This is just length of AR. So you subtract 7.6 from 12.3, you get RT. So, all right, now we have all the side lengths. So the perimeter of triangle ARB is 7.6 plus 7.6 plus 12.3. So 7.6 times 2 plus 12.3 is 27.5. Okay. Now triangle RBT is, the perimeter is 7.6 plus 7.6 plus 4.7. 7.6 times 2 plus 4.7. 19.9. All right, in triangle BAT, BR is congruent to BT and is congruent to AR, and they have that marked. And the measure of angle RBT is 20 degrees. Find the measure of angle T, the measure of angle ARB, and the measure of angle A. All right, so we can start by, if this is, these are the two base angles of this isosceles triangle RBT. So those are going to be congruent. So 2x plus 20 needs to equal 180. So 2x needs to equal 160. So x is 80. All right, and that gives us the measure of angle T. Okay, now the measure of angle ARB is just 180 minus 80. That's going to be 100. Okay, now let's see. The measure of angle A is, so, okay, we've got another isosceles triangle ARB here. So these two angles are congruent. So it's going to be 2x plus 100 is equal to 180. So 2x is equal to 180 minus 100 is 80. X is equal to 40. So the measure of angle A is equal to 40 degrees. Okay, in triangle PMN, PM is congruent to PN. All right, yeah, it's kind of hard to mark that in, but this entire length PM is congruent to this entire length PN. MB bisects angle PMN. So MB, this is a bisector here, and NA bisects angle PNM. So this is another bisector. If the measure of angle P is 36 degrees, well, okay, but we know actually these are going to be congruent because, yeah, this is all congruent because if side PM is congruent to side PN, then that's an isosceles triangle. So this entire angle is congruent to this entire angle. So the bisectors are congruent. The half angles are congruent. So, okay. So now the measure of angle P is 36 degrees. All right, name all isosceles triangles shown in the drawing. So why do we need the measure of this angle then? I guess, well, okay, well, let's just, we can get the measure of angle PMN and PNM because X is the same angle. X plus 36 needs to be equal to 180. So 2X is equal to 144. So X is equal to 72. So 72 divided by 2 is 36. So this is 36. This is 36. Okay. Now, what we can see here is that these two, the triangle PMB is isosceles with these as base angles. So like MB is congruent to PB. So, okay, we've got the isosceles triangles, okay? They told us that triangle PMN is isosceles. They didn't tell us explicitly, but when you say two sides are congruent, then you're kind of saying that. Okay, now we can say that triangle PMB is isosceles because it has two equivalent angles. We can see triangle PNA is isosceles, two congruent angles. We can see that triangle, well, let's see here. Okay, so 36 times 2 is 72. What is 180 minus 72? That's going to be 108. So this is 108. So, okay, 180 minus 108 is 72. So let's see, 36 plus 72. So this is 72 over here. So we have a bunch of isosceles triangles. We've got triangle, they don't give us this point in the middle. Let's call that point O in the middle here. Triangle MOA, triangle NOB, and triangle MON. All of these have a congruent pair of angles. Let's see, what about triangle like MBN? Yeah, triangle MBN, because 36 plus 36 is 72. So triangle MBN, triangle NAM. You see, NAM. Explain why each statement is true. The altitude from the vertex of an isosceles triangle is also the median to the base of the triangle. So yeah, we talked about this earlier. Coming from the vertex of an isosceles triangle, the altitude, the median, the angle bisector, and the perpendicular bisector all coincide. It's all the same line, because if we start with an isosceles triangle and we draw the angle bisector, okay, so this is some random point Q. Well, we know from a theorem that we proved that this is a line of symmetry. It splits the triangle into two separate triangles, congruent triangles. So, okay, the corresponding parts of these two triangles are, so okay, you have the same side there. Those two correspond. Those angles correspond. These angles correspond, so they're congruent, but it's overall a straight angle, so those are right angles. There you go. It's the median. It's obviously the angle bisector. It's also the altitude and the perpendicular bisector. Yeah, so why does the bisector of the vertex angle of an isosceles triangle, why does that bisect the base? That's what we just showed. It's the coming from the vertex angle of an isosceles triangle, you're going to have the angle bisector, the altitude, the median, and the perpendicular bisector all be the same line. Okay, explain why the bisectors of the base angles of an isosceles triangle together with the base form an isosceles triangle. Okay, let's see. So we'll say we've got A, B, C, with C being the vertex angle of this isosceles triangle. So let's draw the bisectors of the base angles, the angle bisectors. So let's try and cut that angle in half. Okay. Cut that angle in half. We can go ahead and draw this angle bisector too, which again we know is going to be the median, etc. So, okay. So we know that these two angles are congruent, and so if the bisection, the half angles are going to be congruent as well. I didn't really draw that. Let me redraw this. Angle bisector, like that. Okay. Now I'll just leave this. So these angles are congruent. And so they're saying that these segments here, so A, B, C, let's see, D, E. So you have triangle ADB and triangle BEA. Are those isosceles triangles? That's what they're asking. They're not asking that. They're telling us to explain why that's true. They're telling us that it is true, and they want us to explain why. All right, well, we can compare triangle ABE and BAD. So these two sides are the same side. Those are congruent. And if we look closely here, we've got two angles of these triangles are congruent. We've got, so for triangle AED, this entire angle is congruent to this entire angle of triangle, so it was AEB to angle BDA, right? But then another angle of the triangle is this smaller angle here. This angle is congruent to this angle. So by angle side, we have congruence of, let me write this, triangle AEB is congruent to triangle BDA. So let's see, the side AE is congruent to BD. EB is congruent to DA. Okay, so what are they asking us to prove? I'm still kind of confused. Maybe they're saying that we want to prove that this triangle here is isosceles. Well, in that case, we can already see that from these two. We have the same base angle here. So these two sides must be congruent. And if those two sides are congruent and these entire AD is congruent to EB, then these sides are congruent. So you have a bunch of isosceles triangles here. All right, in the figure, XZ is congruent to YZ. And Z is the midpoint of XW. So that means all three of these are congruent. Prove that XYW is a right triangle with the measure of angle XYW being 90. So they want us to prove this. Okay. So let's see. We have a couple of isosceles triangles here. That means this angle is congruent to this angle. Okay. And then this angle is congruent to this angle. But just because we have the same side lengths, that doesn't make any statement about, like, oh, well, okay, these two side lengths are the same length of this isosceles triangle. Those two angles are congruent. Well, these are the same side lengths, so that means that these two angles are congruent to these two, obviously because they're base angles, but also to these two. No. We can't say that. We just know that these two are congruent because you have from this isosceles triangle XYZ, and these two are congruent because they're base angles of the isosceles triangle ZYW. All right, so what we can do next is let's say, okay, f plus d plus c is equal to 180. Okay, f plus d plus c. Also, a plus b plus e is equal to 180. All right. Also, b plus c is equal to 180. Okay, and actually we also have, if we want, we could work with a plus e plus f plus d is equal to 180. Okay, but now we've got these congruences, so let's simplify all of this as much as we can, and let's try and conserve any e's and f's, since that's what we're trying to find a relation for. So, okay, f plus d plus c. Well, d is equal to f, so it's f plus c is equal to 180. So you have 2f plus c is equal to 180. Okay, a plus b plus e. Well, e is congruent to b, so let's conserve the e. So we'll have a plus 2e is equal to 180. Okay, b plus c, those aren't congruent, so that just is, would leave that as it is. Now, a plus e plus f plus d. F and d are congruent, and a and e are congruent. So we've got 2e plus 2f is equal to 180. So there we go. Can we make some substitutions here to get a pure relation between e and f? Well, no, we've got it here. We've got it here. Divide both sides by 2. E plus f is equal to 90. There we go. Done. Okay, same figure. You have a is equal to e is equal to 66 degrees, which means that these two sides are congruent. Also, yz is congruent to zw, so these are congruent all to each other. If yw is equal to 14.3 and yz is equal to 7.8, that means this is 7.8 and this is 7.8. Find the perimeter of triangle XYW. All right, so what is 7.8 times 2? 15.6. That's not 14.3. Let's see. Let's take, what is 66 times 2? 132. So what is 180 minus 132? 48. So this is 48 and this is 132. Okay, but now this is isosceles, so f is congruent to d. So 2x plus 132 is equal to 180. So 2x is equal to 48. So x is equal to 24. So this is 24, and this is 24. Now, what is 66 plus 24? 90. So this is a right angle. Therefore, we can use the Pythagorean theorem to get this side length here, this side length x. So, okay, we've got it's going to be x squared plus 14.3 squared, that's the two legs of the right triangle, is equal to 7.8 times 2 is 15.6 squared. So x squared is equal to 15.6 squared minus 14.3 squared. Take the square root of that, you get 6.23. So this is 6.23. So now let's just add all of those sides up. So 6.23 plus 7.8 times 2 is 15.6 plus 14.3 is 36.1.